When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn off. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had. In a fast-paced tech environment, the potential attack surface increases with each release and new app created. Detectify automates cutting-edge knowledge from trusted ethical hackers into the development pipeline for reliable application security. Go beyond the OWASP Top 10. Check your web apps for over 2,000 known vulnerabilities actively exploited in the wild, monitor subdomains for potential takeovers, and remediate security issues in staging and production. Learn more with a free trial at securityweekly.com/Detectify. Go hack yourself. Security teams need visibility into Linux systems to detect and investigate incidents and protect against unwanted activity. Operations teams are not down with downtime, and with revenue tied to uptime, ops priorities are enterprise priorities. Which is a higher priority? Why not both? Capsulate provides flexible, production-ready infrastructure protection for Linux systems, all without a kernel module. With ops-friendly production security, Capsulate delivers monitoring, detection, and response without adding operational risk or cost. Visit securityweekly.com/Capsulate today to request a demo.
Welcome back to a magical Application Security Weekly. I hope the card you picked was the 3 of clubs. I'm your host, Mike Shima, joined by John Kinsella. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher, or our YouTube channel, or our Twitch channel, which we're experimenting at this very moment. You can also sign up for our mailing list, and of course, join our Discord server, which is also pretty active right now. So hello to everyone in Discord. Also, do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions for guests by completing the form at securityweekly.com/guests. We review suggestions monthly and will reach out to you once reviewed. A new segment this week. So we have actually a lot of authentication to talk about, but before we do, I think it's time to pick up a teaser that we mentioned last week around PHP. And so just as we were going on our live stream last week, PHP was announcing they had detected 2 malicious commits in their PHP source repo, and they had revoked them and changed them. It didn't look like the malicious attack or the actor had made any other commits or compromised any live versions or artifacts, but it did highlight a couple, I think, interesting things. And this is not so much specific to the context of PHP as a language, is it secure or not? I think for this is more some conversations around what does it mean to have a secure CI/CD process. So I'll bring you into this, John, to sort of maybe also to find out different areas you might be thinking of. But as kind of a pre-mortem, they detected 2 malicious commits. Broadly speaking, as a rhetorical question, how easily would your auditing capability be able to, with confidence, say that there were only 2 malicious commits? Also, one of the things that was said in the announcement was that the malicious actor was able to sign off as one of the core PHP developers. And there's a very subtle difference between just saying signing off as a developer for a commit, which is basically a +1 looks good to me, versus signing the commit, which is actually a cryptographic hash that says this identity of that core developer actually did approve and submit this, rather than a malicious actor going through some type of vulnerability, unknown still, within their Git repo. So that at the very least, those were 2 thoughts that came to my mind that I think are much more general applicability than beyond just a single PHP code repository.
Yeah, we've been talking a few times now about signing commits. I think as a homework assignment for, we just spent half an hour talking about security shifting left or right or both ways. For anyone listening, security or dev, go spend, I'd say budget 30 minutes. Google about how to add a PGP key or GPG key to your GitHub, and just go walk through the process. It's easier than it used to be, right? The defaults are now secure in PGP. so you don't have to worry about key size and stuff like that. But just go through and add it to your own and set it up so even if it's just for your home project, you're signing your stuff, right? Get the experience and see what it's like. And like this is someone on the thread when this came out last week, one of the developers, she's like, hey, I'm not suggesting this is mandatory, but I've been doing it for a while, and I hope others start doing it as well. It's I think by the end of this year, that should be a goal that any open source project of value should be signing every commit. And like you said, the signed off by, I don't know if that's a header or just a field in a git commit. Yeah, that's just text, right? And that probably that seemed good enough for a long time for many people, but that's just a text string. I'd like to think we'd catch this. I'd like to think most projects I've done in the last 5 years or so would catch this. If you're doing a peer review before, if you're mandating a peer review before a pull request gets merged, you should be able to catch this. The interesting part still to this about me, even I think we saw it last week, was that you mentioned it. The people who did this, they were brave enough that when the commit got reversed, that they pushed it again. That's just that's brazen, man. So props for the huge attachments, but I'm glad you didn't succeed. But that shows you, like, if they're that brazen to do that on a project like that has that much visibility, unfortunately, it does make me question a lot of what we're using. And I know that sounds like an ad for some companies out there that they have all sorts of whiz-bang things to do this, but tread carefully and keep an eye on what you're importing, or when you change versions, or when you bring in a new package. And we've talked about all this stuff, but it's got to take it seriously.
Tread carefully. And I definitely agree. I think the thing you highlight there too about even just throw in a GPG key on your personal repo, just the toy repos that you play with on your spare time, and just to understand and look at what does the signing commits look like. Because I think the other important nuance there is it's quite easy, relatively speaking, to generate a key, to upload it into github.com, for example, import into GitLab for just another repo as an example here. But one of the important things is there's also lessons to be learned in key revocation, as well as, oops, I forgot my passphrase to that key. And that's one of the things too, in the spirit of our last segment, making sure that security acknowledges the developer experience. Forgetting your I'm not even gonna be able to say it right. Forgetting your key can be impactful. It can slow you down. And so this is where hopefully you develop improved developer experience will be something to invest in as well. Whether it is just touching the Touch ID bar if you've got a Mac laptop, or a FIDO-based key, you can just tap a key, like a YubiKey, something like that, and that can help with the signing too. So there are ways to make this better, but I think exercising that will also highlight those important areas of just handling and managing the key over time.
It's funny. So I was going to extend what I was saying there a little bit by saying that homework assignment, and you gave some really good examples there as well. It sounds like we're suggesting something, just go and do something very quickly, but it's the thought experiment around it. It's like I was going to talk about, go a little further and talk about key management. What about if you want to do that git commit from two separate machines? How do you import and export your key? Someone on Discord just mentioned, hey, talk about automation of using a security key vault location. Okay, so if you want to really do that right, where do you want to put that key? So we're starting to veer towards things that you're not going to do on your home box, but as you think about, how do you have that developer do it? If you do backups, do you back up the key? Is the backup encrypted? If you're putting on your work laptop and you're bringing it home, what happens if it gets stolen? Can someone else get access to that key and then commit as you? So it sounds like a really simple thing, but the more and more you think about it, it quickly becomes a lot more complex. This is, key management is not a simple thing. And hopefully that starting and walking through those 5 or 10 steps will get folks a few moments to think about how do you do this.
Absolutely. And then you're going to start just because we like to make things even harder or just let's say rephrase it this way, just because we like to continuously unfold the different layers of how deep you can go in these types of approaches, then you start getting into keys for all of the, services, the automation throughout that CI/CD pipeline. So you now have at what point, artifacts get signed, et cetera, et cetera. And I'm trying to resist mentioning SolarWinds just for the sake of SolarWinds all the time, but it's relevant in this case because the attackers there actually modified code in memory. Modified the artifact in memory in a few microseconds so that it would neither slow down the build process or be noticeable there, because once you slow down a build process, then developers absolutely notice. It's one of your best monitors of all time. But the other thing is that doing the in-memory changes then meant they didn't have to muck around with impersonating signatures, et cetera, et cetera. So I don't mention that to say nihilism, this isn't worth doing, just to say you're going to shift the burden of the attacker to become very sophisticated and a very high effort on their part to pull off these kinds of attacks. So start easy. GPG keys on your personal repos, just do it yourself, and then start to expand, as John said, into key management and build from there. So let's see. Probably we've exhausted that topic. There's a lot to talk about, get into authentication. But there was another soapbox, I'll just make this a short one this time, that I wanted to get onto. And this was made me think of it when I read this Apex Legends players banned for DDoSing server. And DDoS, not necessarily something that is all that earth-shattering, not that something that's necessarily hard to pull off, not necessarily something new. But what I did want to highlight is that this particular type of attack, it's similar to the social engineering attack that was pulled off against Twitter customer service that allowed basically some teens to impersonate Twitter users and post as a handful of Twitter users. This was back in 2020. The threat intelligence or threat modeling doesn't really matter who was doing the attack or what their motivations were. It really just focuses on what was the means of an attack. And this is a little bit of just where I like to highlight from a product security or from an application security perspective. When you go through your threat models, I really, really often just don't care who the attacker is or how well funded are they or what are their motivations. I really just say, well, what if they do a DDoS? What if they do an application layer DDoS versus a volumetric network layer DDoS? What if they do social engineering in this way or this other way? And it doesn't really matter who it is, because the controls you're building, I think for the most part, are kind of independent of that. It's more of, were you aware of this attack vector and did you do something about it? So that's why I wanted to mention this particular article this time around.
So I'm not a gamer. Because I've got a massively addictive personality, and you wouldn't see me on ASW for months if I started playing games. But security around games and things like this are really interesting to me, especially for networked games. I guess I am a gamer from the point of view. I do like Zwift, ZWIFT, cycling app for those on that side of things. Slight tie-in, last segment, someone had a Peloton in the background. So, and I think I might go back and throw a link in on this for one of our upcoming news segments. This was, it was a few months ago. But every few months now, Zwift actually ends up banning people. So what we had during last year with COVID, more and more folks went into Zwift and started, riding when we're stuck at home. But also the pro athletes who are no longer either semi-pro or pro athletes who are no longer able to go and race, they wanted to keep up in form, so they started e-racing. And the guys at Zwift had to start putting more and more time into how do we, catch doping, as it's called. Well, I guess we've talked about here is doping as well. But how do you catch doping when someone's on a bike at home? So they've gotten pretty sophisticated with some of the stuff they're doing, but they're still catching and banning people every few months. And it's, again, cat v mouse, but in a different way than we usually think of. And I'm willing to bet when people were first writing Zwift, the last thing they were thinking about is, well, how do we make sure someone's not cheating on our cycling game, right? So I think your aspect there of your question around what do you think of threat modeling and how do you model this it's a fun one to talk about for a while. So I'll have to bring that back in the future.
Yeah. Plus, you'll have to dust off some of that gaming because we are starting to stream on Twitch now too. But I think the one thing I wanted to add there too is that it's as a security industry, I often hear it's a little bit easy to hand wave and business logic vulnerabilities, which unfortunately are just way too coarse, high level to be interesting, or not to be interesting. They're just too high level because you're really pulling out the context of what is the product, what does the user population look like, and that context is really what makes threat modeling interesting, which is a callback to our previous segment with Leaf, is a great way to have developers kind of lead some of those threat modeling exercises. They have a better context about why they're building something or what is the business purpose of this application. And I think that's what brings out those richer conversations. Either they'll learn from what clever users are doing unexpectedly to abuse the systems, or they're anticipating it and just trying to figure out how to get in front of it. And they're not really worried about SQL injection or cross-site scripting and so on. They're worried about this is how, these are some clever ways that our system is being abused. So don't have a good segue from that other than thinking about broader education. I did highlight 2 articles this week because I've been trying to find more articles, just broad education. One is from Cloudflare that's just about how to execute an object file, which really is about, you don't necessarily need to be an expert on binaries and ELF, what ELF looks like, or dwarf for that matter on different architectures. But what this blog is really neat is just if you want to get into reverse engineering, or if you are designing systems and containers and trying to figure out what's our threat model of a container, just understanding how binaries are compiled, what that compiled binary looks like, what DLLs, or in this case, shared libraries it might pull in. Just those basic concepts I think are just really good to learn so that you can have a better and richer understanding when we talk about ASLR or syscall filtering, things like that. So I wanted to highlight that article in particular. And the other article I wanted to highlight was also on Wizard Zines. And this is something from Julia Evans. She's got a great blog, and she basically brings in some wonderful art and text into the zine format. And from those of you who perhaps not in the early 90s when I came across zines and reading especially Riot Girl zines and also D&D and role-playing zines. They're just a great way of sort of a DIY, share some knowledge. So I wanted to highlight these 2 in particular. And wizardzines.com has a bunch of great topics. You dive into it from everything from binaries as well to command line options for Nmap or most recently strace.
Yeah, she's got I'm just flipping through the list. A zine spying on your programs with strace. Yeah, it's a fun list of stuff she's got in here. It seems like something that'd be good for businesses to buy and give out to their developers, just to give a bit of a plug there. But the Cloudflare Plus, let's try this again. The Cloudflare post tongue twister.
Yeah.
I wish I had like a few hours just to go and actually go through this step by step, because it's while what they're doing isn't, as you said, not rocket science, but if you come into this as part 2, and I think I can't remember if we talked about part 1 last week or I just saw it somewhere, but if you come into this part 2 and you're not really thinking, and just like a little bit of code for a little bit of C code, 2 functions, and then they compile it and run a loader against it, and the results are like completely different than what you expect. So it's got this really sort of smack you across the face and grab you and hold you and make you want to go and look closer. It sort of keeps going deeper. It's the type of stuff I can nerd out to. So it looks like a fun read.
It is a fun read. And I think, too, as a tie back to our last segment with Leaf, that the subtext of our conversation with Leaf was not about every security person needs to learn programming or become a programmer. It was, I think, more importantly, every security person should understand the labor intensity that goes into developing programs, that goes into fixing those bug bounty reports that come in, as well as getting an appreciation for what does a well-designed application look like. And I think this is one of those things in that similar spirit. Just wanted to highlight this Cloudflare post to understand some of what goes on behind the scenes, so that you can just have an appreciation at a high level when we're talking about different threat models, etc. So hopefully enjoy those, whether it's text or text and artwork. Please enjoy those. And in that spirit of what we often talk about here too, is how do we better communicate security concepts or even just engineering concepts? The zine format is a wonderful, wonderful approach. And I do not have the drawing skills, so I probably won't be launching an ASW zine. But we, in the spirit of delegation, John, that's all on you.
Hey.
Sounds like we better switch quickly to the next topic. So let's talk about authentication. So it seemed like this last week was a week of authentication, and as well as even Leaf had brought that up, as they were focusing on SSO. That was their kind of their engineering focus as they were shifting from security into developer engineering. That was the E word I was looking for. So three things here: a general authentication discussion or overview of machine-to-machine authentication in AWS, SAML XML authentication, and then some hidden OAuth attacks. So sort of three different sides to this particular topic. So I'm going to jump on let's see, which one do I want to jump on first? I'm going to jump on the hidden OAuth attack vectors first. And really, this is about making sure your SSO doesn't turn into SSO. And just in the sense of, here are some ways that OAuth could be subverted. And again, really nice write-up talking about SSRF, very dangerous for authentication, as well as cloud environments, as we've seen on a couple other recent articles, talking about redirect URIs, session poisoning, as well as just user enumeration. I will admit that user enumeration is never too exciting for me as a particular vuln, but SSRF is always interesting, and they walk through pretty interesting how to pull this off by playing around with the different ID tokens, redirect URIs, basically different aspects of this OAuth, three-legged OAuth kind of protocol that's been set up. And I think at a higher level, what was I going for here? At a higher level, this just talks about something that I just completely forgot about. So John, help me out here. Save my brain.
That's all good. So, excuse me. I don't know if there was something in the air last week or what, or maybe a month or so ago, but it seemed like there was a few different, beside the two that you've got here, it seemed like there's a few different OWASP articles which came out last week. And I'm not sure if that was, let's try again. A few different OAuth articles which came out last week. And I'm not sure if that's just meeting of the minds or if there's something a little bit deeper going on that I didn't realize. It's funny, I actually do find user enumeration entertaining because I think there's some really creative ways that I've seen pen testers go about doing that. So I think if you're going A to Z, no, Jan, that's boring. If you start going, okay, I've got this dictionary of usernames or dictionary of passwords, what creative things can I do to brute force this through a normal system? I think that can get interesting, and I'll leave that as a thought experiment for a listener. OAuth sounds simple, and it is one of my guys, one of the people I work with was my guy in a previous life, but he's got one or two OAuth questions he likes asking interview candidates, and he'll sort of, we give homework assignments, and we'll go, okay, well, have you thought about this one particular use case? And usually people haven't, but then it's like how can they realize and think about it? And it sounds, fairly simple, and I think we've all heard a lot of people say, oh, just use OAuth. But I think it could be a little more secure by default, I think is the way I would talk about it. But yeah, this does they do a pretty good job of sort of talking through some of these common, or I should say, I guess, well-known issues out there. They're probably not that well-known, but it still does a good job of sort of talking through, thinking about, it's not just slap OAuth on your application and you're good to go. It's there's still a few things out there which can bite you. So it's good to sort of step back again and think about that.
Yeah, and I think they're also nice articles. I like the spirit of that in the sense of interview questions, because there's a lot of things you can unfold in a lot of different paths you could go down in these discussions. One, these articles just give a good intro to what is OAuth at a high level, what's SAML at a high level. But then they go into certain things, like if you look at SAML, that one is talking about XML injection. So a little bit of the OAuth top 10 lives in 2021. Yay, OAuth top 10. But one of the things it points out is that these assertion IDs, they're the attributes within SAML. You could muck about with them, potentially inject with them in vulnerable areas, and then they'll be signed. So there's also this order of operation in the sense that, yes, what does signing mean? Signing means it hasn't been tampered with. It can indicate provenance as well, but it doesn't necessarily mean safe. And that's also, I'll kind of point out in OAuth discussions, it's also a common interview point to say, what's the distinction between authentication, this is who I am, and authorization, this is what I can do. And quite often, OAuth might be a little bit too much over-invested by applications that think, oh, cool, this is how I'm going to handle authorization into the app, et cetera, and so on. And those are definitely concepts you don't want to mix up. So some good lessons. And basically, I'm getting into threat modeling exercises again with these two particular articles.
Well, I think first we need some way for you to authenticate yourself to me before I can really answer that question.
My password is 12345. It's on my luggage.
That's it.
Legit.
And the next, sorry, I gotta make one more joke. Once I see XML, I pretty much close the window. So not quite completely, but this is one of those things I wish would die. Yes.
I was going to say there's hope for that, because that's the great setup as a segue into the AWS article.
Good point. Go ahead.
Yeah, because the AWS article, it covers 5 different mechanisms for machine-to-machine authentication. And I will say this, it's a good, yes, it is focused from AWS, is focused on AWS services, but it's pretty easy to generalize to any of the cloud providers or just in general service-to-service authentication. What I really like about this, it was not that all of these other mechanisms are trash fire and use this one instead. It was formatted as pros and cons for each of these approaches, and a really nice use X when Y. Basically, what's the context of what you're doing? But one of the things it did highlight is that SAML, one of the cons of it is that it's XML. XML has never been human-friendly to read. It's a lot of extra markup in there. It gets really confusing real quickly. And so, one of the pros of OpenID Connect, kind of a superset of OAuth, is just REST and JSON. Much friendlier, especially friendlier for co-hosts named John Kinsella. So that's a good thing already. But I don't know, John, what stood out, if anything in particular stood out from this particular article, how you kind of reacted to it.
Well, the OIDC thing is sort of interesting, because that's also a pretty nice tie back to our article about OAuth, right? I think usually when it's in an automated fashion, I don't see as many of those edge gotchas, but maybe I bet you that's sort of like thinking like API security, and they're probably there. I had 2 thoughts on this. One, I do like that wrap up at the end, use X, 1, Y. That's super handy. But and this is nothing against Amazon. This is for any vendor. I'd love to be sort of the bee or the fly in the wall in the room when they were talking about writing this. Were they thinking about, at least when I think Curb, I think nowadays Azure, since Windows NT and stuff like that are domain controllers. So I wonder if there was some sort of context in the back of their head, sort of going, well, we need to cover this, got to make sure we get those customers. Because that's sort of the thing here, right? I did a talk a week or 2 ago on hybrid computing and the security thereof. And this would have been a really interesting aspect to sort of bring in there. Like, how do you, because as we do more hybrid computing, it's not just about, making sure that we do IAC and getting the IAC secure into the right cloud and blah, 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 blah. But how do you get these things to talk securely to each other is probably a pretty massive point on it. Whether you're going cloud to cloud or going from on-prem to cloud. I always like seeing, where was it mentioned in here? Quick search under, mutual TLS. I always like seeing these solutions which use 509 certs. I don't have a good sense of how often folks do that out there. I know, again, Microsoft uses that in a lot of their either best practices or like on their Sphere chip and that type of thing. But I don't have a really good sense of like how many people out in the wild are actually using TLS in that way.
Yeah, I know that because it's funny because this article there's nothing predicated on what's more secure or less secure.
Yeah.
Its two major dimensions are complexity and convenience, which I think are really important. And that's kind of our other theme of the day today is, developer experience, or perhaps in this case, very much developer experience because of working with machine to machine authentication. And that mutual TLS, the highlight for me is it's a great to do, but setting up a CA infrastructure definitely gets into complexity. But they do have rich metadata. So you can say, oh, do I trust this OU? And these OUs can talk to these other OUs. And so there's a lot of identity that you can put into those certs. And I will say, I am aware that the CNCF has their Spiffy project is very much doing this mutual TLS between services. So here's your service mesh of, certs that talk with each other and have some mutual trust. So all pretty fun. And I think one of the other thing I'll just add quickly on this that I liked is that use this when Y also lends itself to that threat modeling of be aware of this when using X. So in terms of how resistant are the tokens to replay attacks? Do the tokens expose the secret or underlying key material? Think of that and the difference between a signed request versus just a HTTP digest or HTTP basic authentication, things like that. And John, I know you were about to say something, so take us out on your final thoughts.
Ooh, boy, the pressure.
Yeah.
You were saying something there interesting, which I forgot because you said something else interesting. Bad habit. I think where I was really going to go was Amazon has a bunch of really good reading like this between both their blog posts as well as their blueprints they're putting out on the GitHubs. There was, I'm not going to be able to find it. Did I? No, I didn't. I thought I found it fast enough. There was something else that they wrote last week. I want to say it was Kubernetes related. But yeah, where I was going to go back to your other interesting point, I think the cloud native stuff is a lot more TLS-y. So yeah, like you said, Spiffy, the meshes use it, things like that. But I guess my thought was more around either older legacy or newer legacy, those type of guys. Like I think it'd be interesting to see there. But yeah, it's a lot of good stuff, and I hope we've helped people this week to be able to have plenty to read.
Absolutely. And now I'm going to have to go back and see if there's a wizard zine about X509 because, and talk about ASN parsing. That is an episode in and of itself, and security vulnerabilities that have come up there and that potentially could. So I think that we could have even more interesting things for all of our listeners out there. Thank you so much for listening. Thank you to my interesting co-host, Mr. John Kinsella. Thanks to everyone who is joining us in the Discord and on our live streaming on YouTube and Twitch. We are going to see you next week on Application Security Weekly.